Next up, we've got Senamile Masanga, who is from the village, but is now a nuclear scientist and a CERN. She actually just said it's pronounced CERN, right? It's the world's most advanced nuclear researching facility, and she's made headlines for the work that she's doing. So here to give us inspiring words about that line of work, let us all welcome Senamile Masanga.
Greetings to everyone. My name is Senamile Masanga. I am a nuclear scientist, all the way from Kwanongoma and to the world. I would like to thank Sasol for giving me this opportunity to speak with you this afternoon. My name is Senamile Masanga. I want to explain a little bit about the first slide. I'm a proudly South African, hence you see my flag, because I carry South Africa at heart wherever I go, might be outside the country or in Africa. And I am a founder of Senamile Masanga Foundation. I wear so many hats being a scientist. I wear so many hats being a non-executive director in various boards. However, the hat that I'm proud to wear is being a founder of Senamile Masanga Foundation, an organization where we lobby for the advancement of women in STEM. Hence, here we are today. It's all about science, technology, engineering, and mathematics. And then Particitele Consulting, because it's science to solve our own problems. So that consulting, it's a consulting company of which, it's the consulting company of whom I'm a founder of, and I am an executive chairman of, because it's science to solve our own problems. So it's all about solving our energy problems, where I am utilizing my own skill to solve the currently problems that the world is facing, because energy is not only a South African problem, it is a global problem. So, where it's all started from, small beginning, from the village, deep Kwanongoma. As you see there, that is my hometown, everybody. Just that one road, and as you see, dirty and dusty of Kwanongoma. Thank you so much. And then, University of Zululand. I didn't go to UCT. I didn't go to University of Stellenbosch. I didn't go to VETS. I am a proudly product of a disadvantaged institution called University of Zululand. I'm sure some of you never ever even heard of University of Zululand. It's in KwaZulu-Natal. It's one of disadvantaged institution. There, somewhere there around that picture, I also didn't go to a private school. I attended a public school just like everyone else. Why is this? Why I'm highlighting this? I'm highlighting this because it doesn't matter where you started. Here I am today. I am a nuclear scientist from small beginning, from the village to the world. To being a first African woman to be part of an African-led experiment at CERN. CERN is in Switzerland. It's one of the largest laboratory in the world. It's every scientist's dream, it's every professor's dream to be at CERN. As you see there, myself on the red top, amongst the boys, who run the world? It's girls. It's girls, girls, girls. I wish I'm with you right now, but let's fast forward. First African woman to be part of an African experiment at CERN. It means African child, it is possible. It doesn't matter whether you are female, whether you are from Nongoma, just like myself, because Nongoma, if you go to social media right now, there are a lot of jokes around Nongoma, but here there is Senamile Masanga, who is from Kwanungoma, who is a first African woman to be part of an African-led experiment at CERN, one of the biggest laboratories in the world. Okay, what is this nuclear scientist? I know most of you think of nuclear science, you think of bombs, oh, she's going to kill us, he's going to make a bomb. You know, we just witnessed the war, Ukraine versus Russia. They are using nuclear bombs. So what is it all about? And why is it interesting? Okay, first and foremost, we want to know how is the world is built, right? I'm sure all of you will all know about an atom. An atom has an electron. Then inside, you will shade something dark. You say, aha, this is your nucleus, right? This nucleus, it's very, very small. You cannot see it in your naked eyes. However, you know that it's there. So it's not within this dimension. It is on the other dimension where you can see X, Y. It's in the other dimension where you have 5 coordinates. Yes, when you are studying small things, you are not in this dimension. You tap into another dimension. So, we believe as scientists that everything started from the other dimensions, right? Hence, we are all interested to study up space in other planets and so forth, because everything starts in the other realm before it's manifest here in this realm. So it will give us so many answers that are so fascinating and curious, where we are all curious about. Like, for instance, when was the universe created? We all know about the Big Bang, right? Everything started in the Big Bang, where the stars are coming from, why is the sun is like this, and so on. So we try to answer this question. Hence, we study nuclear science. So if you are a little bit curious, if you are a little bit want to understand why things are there, here, no there, no there, no there, nuclear physics is the field. So the nuclear story, what is it all about? Hang on, let us imagine ourselves, like as you see there on the screen. It's in the stadium. Imagine an atom, the one that I explained. It's a football stadium, and the nucleus will be a P at the center of the stadium. Then where people sit, it's the electrons whistling around. Everything in between is an empty space. This nucleus, it is very small. You cannot see it by your naked eyes or observe it, but you know it exists through measurables when you measure the energy. So this nucleus, it's a many-body system. Right, we know within the nucleus we have the neutrons. The neutrons, they are neutrals. And then we also have the protons, of which the protons are charged, right? However, there's something that is very interesting that happened between these two particles. The other one is charged, and the other one is neutral. But there are things that hold this thing together, of which is, does it make sense? No, it doesn't. So what is holding these particles together? So we believe as nuclear scientists that there is a strong interaction. The nuclear force that is inside the nucleus. So why is it relevant? It is relevant because it will lead us to what is happening around the world. Again, if we understand this nucleus, many applications will come from it. For instance, if I can drop this remote, it will go down. Why? Because of a gravitational force. So we understand the gravitational force very well, hence we have applications of aeroplanes. So in order for an aeroplane to fly up high, it needs to beat this gravitational force. So what about this one? This strong interaction that happens between the neutrons and the protons, right? So the nucleus, it's very small, I've already said it, and it comes in 3 different shapes. As you see on the screen, you have a spherical shape, and then rugby ball, then you have the rugby ball squash shape. So it is a very complicated system inside. However, it is possible. So where does this thing can lead us to? Firstly, some of you are currently, not some, all of us, we are currently experiencing load shedding. So if you study this nucleus, you can do nuclear applications where you can fuse these 2 nucleus and get energy from it, or you can split this nucleus and get energy from it. Again, there is a proton therapy to treat cancer. So those who are also interested in the medical field, you can be a medical physicist where you use this nucleus to treat cancer. And then scientific research like myself, I'm a scientist that does research of fundamental physics. You can also explore space, and also you can also change the seawater to be drinkable. So what do I do as a nuclear physicist? I am a nuclear experimentalist. So I prove the theory by performing experiment like determining the shape of this nucleus. Remember the shape that I told you about. So there is me there at CERN performing the experiment. So in order for you to perform the experiment, you have to be good in mathematics, you have to know how to code, you have to know the electronics that are happening. Hence, as you see there by those racks, it's electronics racks. So let us watch here. How does it work?
It marks the beginning of the world's largest and most powerful particle accelerator chain, culminating in CERN's spectacular Large Hadron Collider. Hydrogen atoms from this gas cylinder are fed at a precisely controlled rate into the source chamber of a linear accelerator, CERN's LINAC 2, where their electrons are stripped off to leave hydrogen nuclei. These are protons and have a positive charge, enabling them to be accelerated by an electric field. Their journey to eventually take part in ultra-high energy collisions, similar to those following the Big Bang, can now begin. This initial acceleration has caused LINAC 2 to be likened to the lumbering first stage of a huge rocket. By the time this packet of protons leaves LINAC 2, it'll be travelling at 1/3 the speed of light. It's about to enter the booster, stage 2 of the rocket, if you will. In order to maximise the intensity of the beam, the packet is divided up into 4, one for each of the booster's rings. Straight acceleration is now impractical, and the booster is circular, 157 metres in circumference. In order to accelerate the packets, they are repeatedly circulated, and the electric field is now pulsed, in the same way that you push a child on a swing each time they reach a certain point. Magnets exert a force on the passing protons at right angles to their direction of motion, and so powerful electromagnets are used to bend the beam of protons round the circle. The booster accelerates the protons up to 91.6% of the speed of light and squeezes them closer together. Recombining the packet from the 4 rings, it's then flung on into the proton synchrotron, by analogy, stage 3 of our rocket. Let's just follow 2 such proton packets. The proton synchrotron is 628 meters in circumference, and they circulate for 1.2 seconds, reaching over 99.9% of the velocity of light. It's here that the point of transition is reached, a point where the energy added to the protons by the pulsating electric field cannot translate into increased velocity, as they're already approaching the limiting speed of light. Instead, the added energy manifests itself as increasing mass of the protons. In short, the protons can't go faster, so they get heavier. The microscopic kinetic energy of each proton is measured in units called electron volts, and now the energy of each proton has risen to 25 giga-electron volts, or GeV. The protons are now 25 times heavier than they are at rest. The packets of protons are now channeled into stage 4, the superproton synchrotron, a huge ring 7 kilometers in circumference, designed specifically to accept protons at this energy and increase it to 450 GeV. Soon, the packets of protons will be energized sufficiently to be launched into the orbit of the gigantic Large Hadron Collider, or LHC, which lies between the Jura Mountains and the Alps, and straddles both France and Switzerland. Lying deep underground, it has a circumference of 27 kilometers. There are 2 vacuum pipes within the LHC containing proton beams travelling in opposite directions. Using ultra-sophisticated kickers to synchronize incoming packets with those already circulating, one vacuum pipe has injected into it protons which will circulate clockwise, and the other protons which will circulate anti-clockwise. The counter-rotating beams cross over in the 4 detector caverns, where they can be made to collide. The energy of the collision is double that of the individual opposing protons, and it's the debris from these collisions that is tracked in the detectors. For half an hour, the SPS injects protons. Finally, there are 2,808 packets. During this time, the LHC adds extra energy to each proton, whose velocity is now so near the speed of light that it goes round the 27-kilometer ring over 11,000 times each second, getting a boost of energy at each revolution from the pulsed electric field. Finally, each proton has an energy of 7 tera-electron volts, and they're 7,000 times heavier than at rest. The magnetic force needed to keep the beams bending to the ring is so enormous that nearly 12,000 amps must flow through its electromagnets. This is achieved by making the LHC colder than outer space, so that its magnets become superconducting. Now the protons are ready to collide in the detectors. A steering magnet finally brings them onto a collision course. The total energy of 2 protons colliding in the LHC is 14 tera-electron volts and reproduces similar states to moments after the Big Bang. Particle tracks from these collisions will be analysed by computers connected to the detectors, and it's hoped these tracks will give a new insight into the very birth of our universe, how our universe has evolved, what governs its behaviour today, and where it's going in the future.
Wow, where it's going in the future. So basically, this is what happened in the Big Bang, the birth of our universe. So as scientists, we are trying to understand how, as human beings, we're coming from, where this Earth is coming from, where is the other planets are coming from. Isn't this fascinating? I was so fascinated as an 11-year-old when my geography teacher introduced us to astronauts, and astronauts are those people who travel to space. And I learned that there are few women within the science field, and I wanted to make history to become a first African woman in space. Here I am today. I am a first African woman to be part of the first African-led experiment at CERN. So you accelerate this proton that we spoke about. I'm sure everyone knows protons, to be equivalent to the speed of light. That is hectic. And all this experiment does not happen above the ground. It happens under the ground. So let's come back. So there is quantum physics for babies. You have a ball, right? A ball has a zero energy. As you see, this is the ball. When you move the ball, it's the ball with energy. And all the balls, they are made of what? Of atom. We're all made of what? Atoms, right? The atoms, they have neutrons and protons and electrons. Electrons have what? They have energy. This electron has the most energy, the one that is higher there. The electron has the least, that is below. The energy is what? Is quantized. An electron can be on that level, can be on the other level, can be here, but not here, or here. There are not electrons with zero energy. They need to move. An electron can take energy. To jump, you need energy to jump. To go down, you need energy. You can give. You also give what? Energy. Remember, E is equal to mc squared. We are all energies, right? So the amount of energy is quanta. Now you are a quantum physicist. So this is what is happening to the unseen world. Definitely, if you hate physics, then you probably learn it from a wrong teacher, because physics, it is fascinating. So we made history. Nothing is impossible with a correct mindset. I always tell young people that you don't need money. Yes, you don't need money. The only thing that you need is a correct mindset. I've done a lot of things without money because I have a correct mindset and I have achieved all those things. So be protective of your mind. What you read, what you see on TV, what you see on social media, because you need to feed your mind with only positive things. With a correct mindset, you will move mountains. Remember where it started, from the village. And then from making use, even receiving an acknowledgement from my former, it was the president of that time, our former president, President Jacob Zuma. So you can go and Google about this, and if you are curious, you can also see there are a lot of information in the internet. Instead of TikTok, tonight you are going to check about what is the CERN it's all about. Maybe she's a straight A student. No, I'm not a straight A student. I have a correct mindset and I work hard. So we need also to work hard. You see, 3 a.m. there is a physicist that is up. Definitely that picture was taken at 3 a.m. Fast forward, masters in nuclear physics passed with cum laude. Cum laude, it means it is a distinction. Remember, small beginnings from the village, from the dusty to Kwanongoma, here, cum laude. It means nothing is impossible. You can also make it. Those who want to be scientists, they can also make it, because you are not defined by your village. You are not defined by your situations. You are not defined by where are you coming from, right? Yes. So we need to seek growth, get involved, be out there, and be relevant. As wherever you are right now, you are trying to be relevant, knowing about robotics, knowing about new technology, get involved. As the world is moving, we owe to ourselves to also move with times. Do your research. What are careers that are relevant, right? Because most of the careers are going to be phased out because of the 4IR. Things were now moving from analog to digital. So as young people, as learners, we owe it to ourselves to know where are we going to as the country or as the world in total, because it is going to affect us. We cannot be interested in careers that are not going to be relevant in 20 years' time. So go out there, be relevant. So this is the challenge to ourselves. Hence, I'm here, because I'm a pro-scientist. From the lab to society. That is what I usually tell young people. Because most of us as scientists, we don't want to communicate, we're happy, comfortable in our own lab, but I am a different one. Hence, I'm here to encourage you, to motivate you, to choose science subject, because it is important for us to do science, because with science, we solve our own problem. And education is key to our economy. Education is relevant. I'm here, I choose what I want to do anytime, any day, because I have that freedom because of education. Any country that invests in education has a future. We will have sustainable development. I'm longing for that independent South Africa where our own scientists like myself, we utilize our own skills and solve our own problem, because it is important that we must, once we study that science, we must have a plan. What are we going to do with science? What is the world is facing? Currently, I did mention that I have a consulting company that deals with energy issues. So it's not only about me being curious and so forth. You owe to ourselves to solve our problem, because science ensures sustainability. Without science, there will be no these visual talks. Without science. Without science, there will be no this mic, there will be no screens, there will be no flights, there will be no cars. Water, all those things need scientists, right? Education is at the heart of innovation. That everything that we see around us, new discoveries such as technology, they will never have happened if it not for research, if it was not for science. Another video here is at CERN. As you see, it's men's world. We need more women. We need girls to participate in science.
About the determination, the accurate determination of the shape of selenium-70 at the first 2+ state.
Now, what we're studying here is a radioactive element, which decays to arsenic-70, then back to germanium. So germanium is quite stable, which is, you can access it easily.
So we're going to be using a technique called Coulomb excitation. Back home in South Africa, we are able to produce stable beams only. So unfortunately, we cannot perform the experiment home. Hence, we came to CERN to try and perform the experiment here.
South Africa just became a member of Sasol last year, and this was the first experiment led by an African institution at CERN. So it's for us a great motivation to get things done properly, and as you can see, we have lots of students coming, and it's a great excitement for them to be able to be part of making history, basically.
It's so amazing to be at CERN. As it stands right now, I really want to do great things, and I'm so motivated. I want to do more. I'm hungry for knowledge.
The experiment is important for the science. We're doing very interesting state-of-the-art nuclear physics. But I think the other very important aspect of this experiment is the opportunity it's brought for young people to come from South Africa to get first opportunity for South Africans to lead an experiment in collaboration with us from York here at CERN.
I'm so proud of myself to be such a only woman in this experiment, and I feel like I'm representing all other women from Africa, and I would like to motivate other women as well to come to science, to come to physics.
First thing, it tells people in South Africa that if we can do it, a historically disadvantaged institution can do it, any university in South Africa can do it. And this creates hopefully a domino effect which will sound everyone that anything is possible.
Yes, anything is possible. From the village to the world, that video was taken in Switzerland. At CERN, one of the biggest facilities in the world. So everything, it is possible. Skip this. A future, I will be biased. I know that we also have boys, but not leaving boys behind for sure. The future is female. The absence of women of STEM, education, careers affect all of us as women, and it is a missed opportunity. As women, we bring different perspectives. Again, we need to encourage our girls to be scientists, our girls to be engineers, our girls to be innovators. Set your goals high and don't stop until you meet your president. Thank you so much. My name is Senamile Masanga. I am from Gwanongoma. I am a nuclear scientist. Thank you.